Hello friends, uh, we are meeting again. I am Dr. Kushal Kanno, delivering second lecture on prerequisites on electrical measurement and instrumentation. So before going ahead, we'll have a summary of previous lecture, what we have gone through in my last lecture. We have studied different types of resistors, fixed, variable, linear and non-linear resistors and its applications. We have found that the characteristic of different types of resistors are same on both AC and DC, but there is a difference between AC and DC resistance. We know that resistor is a passive element, or we can also call it as a passive component. Now we will again brush up some applications of resistors. Resistors are used for current control and current limiting. It can also be used to change the electrical energy in the form of heat energy. As a result, as a shunt in ampere meters, as a multiplier in a voltmeter, it can be used to control the temperature. It can also be used to control the voltage or drop in voltage. It can be used for protection purposes, example fusible resistors, and we all know that it is used in the laboratories also. It can also be used in home electrical appliances like heater, iron, immersion rod, etc. It is widely used in electronic industries. So these are few applications of resistors. Now today we are going to deal with active and passive components. What are they? And we will be discussing one of the passive component. Now what according to you are active and passive components? Can you name something? Name a few components. Now these are active and passive components. You can see it on your screen. We have already seen the passive component resistor in our last lecture. Today we are going to deal with inductor, which is one of the passive component, and later on we will deal with the capacitor. Now if you find this part to the right hand side, they are all passive components, and to the left hand side they are called as active components like diode, transistor and SCR. So let us see what is the main difference between active and passive components. Now we can define active components are devices or components which require external source to their operation. They are called as active components. For example, diode, transistors and SCR. We know that diode will not conduct the current until the supply voltage reach to 0.3 volts in case of germanium or 0.7 volt in case of silicon. Whereas passive components are those devices or components which do not require source to their operation. These type of components are called as passive components. For example, resistor, capacitor, inductor, etc. We know that when we connect resistor to the supply voltage, it starts working automatically without a specific voltage. So this is why we call resistor as a passive component. If we move further, then we can have some differences between active and passive components. One of the differences, the devices or components which produce energy in the form of voltage or current are called as active components. For example, diodes, transistors, SCR. SCR stands for silicon controlled rectifier. They are called as active components. Whereas devices or components which store or maintain energy in the form of voltage or current are known as passive components. For example, resistor, capacitor and inductor. So in short, we can say that active components are energy donor, whereas passive components are energy acceptor. Now we are going to discuss a passive component called as inductor. Now you all know what is inductor. You have studied this earlier. So what is inductor according to you? Now we can define inductor as inductor is one of the most used electrical components in a circuit. It is referred by many names such as choke, coil or reactor. It is a two-terminal passive electrical component that store energy in a magnetic field. This magnetic field is produced due to the current flow through it. It is basically made up of a coil surrounding a core. Every coil is an inductor. An inductor opposes any change in supply current. This is the property of the inductor. Inductance is the ability or property of inductor to produce an electromotive force due to change in electric current. So this is what do we call it as a property of the inductor. Now these are various types of inductors and its symbols. So some of the types are mentioned here under the category of air core. This is a symbol of fixed inductor. This is a symbol of variable inductor. You can see that there is a symbol, a line and an arrowhead indicating the variable inductor. This is called as preset, and this is how it looks like, air core inductor, the shape of the air core inductor. Whereas the second category is iron core inductor. So along with this, if you compare it with the air core, then you can find these are the two parallel lines close to this symbol of air core. So this indicates the iron core of the inductor. That's why the name is called as iron core. Similarly, this is a variable iron core and a preset iron core. Now if you compare the picture of these two, then you will find that there is no core in this image, whereas you are finding that the coil or the winding is wound over the core material. This is the iron material. That's why the name is iron core. Here the core is air or the medium is air. That's why the name is air core. The third category is ferrite core. It is a type of material, magnetic material. So ferrite core, the symbolic representation is an inductor, a air core inductor along with the parallel lines, but the lines are dashed lines. As compared to this, you can identify how it is distinguished from iron core. Similarly, the variable ferrite core, the preset ferrite core, and this is how it looks like. This is a ferrite material, that is the magnetic material on which the winding is wound. So these are some types of inductors and its symbols. So we will see few more symbols in our next slide. These are various types of inductors and its symbols that are available. This is a generic symbol, inductor. We all draw the inductor in this manner. This is silicon core inductor. You can find how the core material is shown. Iron core inductor, just now we have seen. This is again a representation of iron core inductor, a ferrite core inductor, inductor with polarity. This dot mark is called as the polarity of the inductor. Then this is analog delay line. This is one of the type of inductor. This is variable ferrite core inductor. We have seen just now preset ferrite core, continuous variation inductor. So this line indicates continuous variation. Variable ferrite core inductor, then variable inductor, stepwise variable inductor. This is the symbolic representation of stepwise variable inductor. This is again one more symbol of stepwise variable inductor. Then this is an inductance, a square, rectangular square. Then inductor, international symbol of inductor. Inductance with power points. These are the 3 points. Shielded inductor, electromagnet solenoid, again the symbol of electromagnet solenoid, electromagnetic deflection coil. Then this is bifilar inductor. You can find two different inductors one above another. Inductor with fixed connections, variometer, saturable core inductor. This is an electromagnet. This is preset ferrite core inductor, and this is electric motor inductors. So these are different symbols of inductor. Now inductors is available in the range of 1 microhenry to up to 20 henry, depending on the applications we can select, we can design the inductor. These are various parameters of the inductor, or you can say specifications. It is specified in terms of DC resistance represented as RDC or DCR, then saturation current. The saturation current uh, in air core inductor, it do not have any saturation current because it do not use any core material. Then rated current, core permeability, self capacitance, self resonant frequency, and power loss in inductor. There are various losses in the inductor such as copper loss, hysteresis loss, and eddy current loss. Now the inductance of the inductor depends on these different parameters. So these are the factors which decides the inductance of the inductor. First factor is length of the coil. You can see that if the length of the coil is more, then the inductance is less, and it is exactly opposite to this length. The length is less as compared to this, the inductance is high. It also depends on cross-sectional area of the coil. If the cross-sectional area of the coil is more, then the inductance is high, otherwise it is less. Similarly, it is directly proportional to the number of turns. If the number of turns are more, then the inductance is high, otherwise it is low. Permeability of the core. So if we are using some magnetic material, then the permeability will decide the inductance. So it is high if we are using some magnetic material, whereas it is low in case of air core inductor. So these are the factors that decides the inductance of the inductor. These are some uses and applications of inductor. It can be used for frequency selective circuits, which are called as filters, such as high pass, low pass, and band reject filter. It can be used for tuning circuit in TV and radio. It can be used as a sensor, transformers, electromagnetic relay, induction motors, oscillators, and isolators. These are various types of inductors. You can go through it. Different types: air core, ferromagnetic or iron core, ferrite core, iron powder core, ceramic core, laminated steel core, toroidal core, drum or bobbin core, multi-layer, thin film, molded inductor, coupled inductor, power inductor, radio frequency inductor, chokes, or variable inductors. So we'll see a few inductors now here one by one, how they look like. So these are air core inductor. You can find that there is no magnetic material involved, so they are called as air core inductor. This is how I am just showing you the pictures of different inductor now. This is ferromagnetic iron core inductor. This is a ferromagnetic material that is used to construct this inductor. This is ferrite core inductor. This is a magnetic material made up of it is a ferrite core, and on which the winding is wound. This is called as ferrite core. This is iron powder core inductors. This is how it looks like, iron powder core. This is ceramic core inductors. You can find that the inductors is constructed on the basis of ceramic core. This is laminated steel core inductor. So on the you can see these are laminations and the winding is wound on it. This is toroidal core inductor. You can see a circular type of inductor and a winding wound on it. It is called as toroidal core inductor. This is drum bobbin core inductor. You can see that this is a drum type structure, or you can see it as a bobbin and a coil is wound over it. This is a multi-layer inductor. These are terminal pads. This is the coil. So you can see this is how it looks, multi-layer inductor. This is thin film inductor. You can find here a spiral copper trace is there, and these are the terminals. So you can see that just like a spiral, it is wounded. This is molded inductor. This is how it looks like. This is coupled inductor. This is radio frequency inductor, and these are the variable inductors. So you can see that there are some rolling contacts. So based on this, we can change the value of inductance. So today we'll stop here. Thank you very much for patience listening. Have a good day.